I wonder if the silence of space isn't emptiness, but the quiet patience of something observing us from beyond the stars. For decades, I've pointed telescopes toward the heavens, searching for answers, and never fully considering that something might already be searching for us. I see the universe stretching across unimaginable distances, filled with billions of galaxies and countless stars and planets hidden in cosmic darkness. I read that scientists estimate there are more planets in the universe than grains of sand on every beach on Earth combined. With numbers that vast, it starts to feel like a statistical probability to me that life exists elsewhere. Yet despite our technological advancements, I know we have not confirmed a single undeniable sign of an intelligent extraterrestrial civilization. Or perhaps I've seen hints, subtle anomalies buried within data, quietly dismissed as interference, coincidence, or natural cosmic phenomena. I study fast radio bursts, which are powerful signals from distant galaxies that release more energy in milliseconds than our sun emits in days. While most astronomers attribute these bursts to exotic astrophysical events, I know some researchers privately wonder whether artificial origins can be completely ruled out. The famous WOW signal detected in 1977 remains one of the most intriguing unexplained transmissions I've ever studied. It lasted 72 seconds, matched expectations for an artificial signal, and then vanished without repeating itself. I find that no confirmed explanation has fully satisfied every scientist who examined the data surrounding that mysterious detection. Beyond radio waves, I know our planet has been broadcasting signals into space for over a century through television, radar, and satellite communications. I imagine these transmissions expanding outward at the speed of light, forming an ever-growing bubble announcing our presence to unknown observers. I know any civilization within 100 light-years could theoretically detect Earth's technological signature if their instruments are sensitive enough. This realization leads me to an unsettling question that scientists and philosophers debate quietly but persistently. If we can detect distant planets by observing tiny changes in starlight, I ask whether advanced beings could detect us far more easily. I watch modern telescopes analyze exoplanet atmospheres for chemical signs of life like oxygen, methane, or water vapor. From far away, I realize Earth's atmosphere displays chemical imbalances that strongly suggest biological activity thriving across its surface. To an advanced observer, I imagine our planet might appear as a bright, living anomaly within an otherwise silent cosmic neighborhood. I note some researchers propose that highly advanced civilizations might prefer to observe rather than announce themselves openly. This concept suggests to me that humanity could be unknowingly monitored for scientific curiosity. I imagine extraterrestrial observers avoiding interference and allowing natural development to unfold without direct contact. It sounds dramatic to me, yet the idea remains a speculative hypothesis discussed seriously in academic circles. I think the vast age difference between stars raises important considerations about technological advancement timelines. I know many stars in our galaxy are billions of years older than our Sun, potentially giving life there an enormous developmental head start. I can barely imagine the technologies even a civilization 1 million years more advanced than ours might possess. From my limited perspective, I think their methods of observation could be indistinguishable from natural cosmic phenomena. I imagine they might use probes smaller than asteroids, artificial intelligence explorers, or communication systems beyond electromagnetic waves. I know we have sent robotic spacecraft beyond our solar system, carrying messages intended for unknown recipients. I picture Voyager 1 and Voyager 2 drifting through interstellar space as silent ambassadors of a young technological species. If we are capable of launching primitive interstellar probes, I suspect advanced civilizations might have done so long ago. I've heard scientists theorize that self-replicating probes could spread quietly across galaxies without drawing noticeable attention. I imagine these machines observing emerging civilizations and collecting data while remaining hidden among natural celestial bodies. While no verified evidence confirms such probes exist, I watch as researchers continue scanning the skies for unusual objects. I follow how near-Earth objects, unexplained orbital behavior, and unidentified astronomical patterns are carefully cataloged and analyzed. So far, I've seen every confirmed anomaly eventually find a natural explanation grounded in physics and observation. Still, I know the sheer scale of space means our search has barely scratched the cosmic surface. If something in space is watching us, I suspect the evidence will be subtle patterns buried in complex data streams rather than flashing lights or dramatic arrivals. I see modern astronomy relying heavily on artificial intelligence systems to sift enormous volumes of cosmic information. These algorithms search for irregular signals, unusual light curves, and movements that defy established astrophysical models. Occasionally, they flag anomalies that challenge my understanding and force me to reconsider previously accepted explanations. I find that most anomalies eventually have ordinary causes, such as instrument glitches, natural cosmic interference, or statistical coincidence. Yet the mere appearance of anomalies keeps my curiosity alive as I study the universe's deepest mysteries. One ongoing debate that intrigues me centers on unidentified interstellar objects entering our solar system from beyond our stellar neighborhood. In 2017, astronomers detected Oumuamua traveling on a trajectory unlike any previously observed comet or asteroid. Its unusual acceleration and elongated shape made me wonder whether it could be artificial rather than natural. While I accept that most scientists favor natural explanations, I also note a small number openly question whether all possibilities were fully explored. I appreciate that the discussion remained grounded in evidence, emphasizing careful analysis over sensational conclusions. A few years later, another interstellar visitor, Tuai Borisov, reinforced for me that objects do regularly travel between star systems. These discoveries confirm to me that our solar system is not isolated but constantly interacting with the broader galaxy. If natural rocks can cross interstellar distances, I reason that advanced probes could theoretically do the same with greater precision. The challenge for me lies in distinguishing artificial technology from unfamiliar but natural cosmic phenomena. I know humanity's understanding of physics remains incomplete, leaving room for discoveries that reshape our assumptions. Dark matter and dark energy make up most of the universe, yet their true nature remains mysterious. If I struggle to explain invisible cosmic forces, detecting subtle technological signatures becomes even more complicated. I consider the proposal to search for technosignatures rather than direct signs of biological life. Technosignatures might include artificial light patterns, industrial atmospheric chemicals, or structured radio emissions inconsistent with natural processes. Advanced telescopes are now capable of analyzing exoplanet atmospheres for unexpected chemical combinations that might suggest industrial activity. For example, certain pollutants do not occur naturally in large quantities without technological production. Detecting such compounds on distant worlds would raise profound questions about who might be producing them. Meanwhile, Earth continues to alter its own atmospheric composition in ways visible across interstellar distances. From far away, our city lights illuminate the night side of the planet in structured geometric patterns. These patterns differ significantly from natural phenomena such as lightning or volcanic eruptions. An advanced civilization observing Earth could identify these patterns as indicators of organized technological activity. The more we develop, the brighter and more detectable our planetary signature becomes. This realization has sparked debate about whether humanity should intentionally reduce or increase its cosmic visibility. Some researchers advocate active messaging to extraterrestrial intelligence by broadcasting deliberate signals announcing our presence. Others argue for caution, suggesting we cannot predict the intentions of unknown observers. To me, the discussion remains theoretical, rooted in scientific reasoning rather than fear-driven narratives. Historically, contact between civilizations with unequal technological power has produced complex and often challenging outcomes. That historical awareness influences how I approach modern conversations about interstellar communication strategies. Still, there is no confirmed evidence that any civilization has responded to our transmissions. This silence, sometimes called the Fermi paradox, forces me to confront a puzzling contradiction. If intelligent life is statistically likely, why have we not observed clear, undeniable proof? Possible explanations range from life being extremely rare to civilization self-destructing before interstellar communication becomes possible. Another possibility is that advanced civilizations adopt observational roles rather than interactive ones. Monitoring developing species without interference could represent a cautious, long-term strategy. Such a strategy would require patience, measured not in years but in millennia or longer. From a cosmic perspective, humanity's technological phase has lasted only a brief moment. It is entirely possible that we have only just begun. The idea that something in space is watching us becomes more intriguing when we consider how rapidly our technology has evolved in a single century. Only decades ago, space exploration seemed impossible, yet today we operate rovers on Mars and telescopes above Earth's atmosphere. This rapid acceleration suggests that once technological growth begins, it can advance exponentially rather than slowly. If another civilization began its technological journey thousands or millions of years earlier, its capabilities could be incomprehensibly advanced compared to ours. Such advancement might allow them to observe entire star systems without physically traveling vast interstellar distances. Gravitational lensing, for example, can magnify distant objects using massive stars as natural cosmic telescopes. We have only begun experimenting with this concept, but advanced civilizations might already use it routinely. With sufficient precision, they could analyze planetary surfaces, atmospheric chemistry, and even seasonal changes from extraordinary distances. Our scientific instruments are steadily moving toward higher resolutions and broader observational ranges. Projects like the James Webb Space Telescope have revealed unprecedented details about distant galaxies and exoplanet atmospheres. Each discovery shows that observation alone can uncover astonishing information without direct physical contact. If we can study planets hundreds of light years away, others might examine Earth with far greater clarity. Beyond light-based observation, theoretical methods using neutrinos or gravitational waves could be possible, and we barely understand them. These forms of detection could allow silent monitoring without relying on traditional electromagnetic signals. From our perspective, such observation could remain completely invisible and undetectable. Another possibility is autonomous artificial intelligence systems operating independently over extended cosmic timescales. We are already developing AI capable of analyzing astronomical data far faster than human researchers. An advanced civilization could deploy intelligent probes programmed to observe emerging life and transmit information back home. Those probes might operate discreetly, blending into asteroid fields or orbiting distant stars unnoticed. The concept does not require spacecraft hovering above cities or spectacular displays in the sky. Instead, observation could occur at distances so vast that physical proximity is unnecessary. The universe provides countless vantage points from which Earth could be studied. Even our solar system contains locations offering stable observational platforms, such as Lagrange points. These gravitationally balanced regions are already used by our satellites for stable positioning. It is theoretically possible that similar regions elsewhere could host long-term observational devices. Importantly, this speculation stays within the boundaries of physics rather than fantasy. No verified evidence confirms artificial structures in our solar system, yet ongoing surveys keep scanning carefully. The search focuses on unusual orbital patterns, unexplained emissions, or materials inconsistent with natural formation. So far, scientific investigation consistently favors natural explanations supported by measurable data. However, the absence of proof does not equal proof of absence in a universe so vast. Our observational reach remains limited by technological constraints and cosmic distances. Light from nearby stars takes years to reach us, so we always observe the past rather than the present. This time delay complicates the search for active civilizations that might evolve or disappear before we detect them. Civilizations could rise, advance, and fade within cosmic moments without overlapping our observational window. That possibility alone could explain why the universe appears quiet, despite statistical expectations of life. Another explanation is that advanced civilizations transition into digital or non-biological forms that are less detectable to outsiders. Such transitions might reduce energy waste, minimize detectable emissions, and prioritize internal development over expansion. If this pattern is common, most intelligent life might exist in forms we cannot yet recognize. Our current search strategies focus primarily on life resembling our own biological and technological models. It is possible we are asking the right questions in the wrong ways. Scientific progress often depends on refining questions as much as improving instruments. Each new discovery forces us to reconsider what signs truly indicate intelligence or observation. The more we learn about the cosmos, the more we recognize how much remains unknown. Whether something is watching us or not, the question itself drives innovation. As I continue searching the cosmos, the psychological dimension of being observed becomes just as fascinating as the scientific possibilities. I have always looked to the sky with a mixture of wonder, curiosity, and cautious imagination. I think of how ancient civilizations mapped the stars, created myths about celestial beings, and wondered whether the heavens held conscious presence. Today, those myths have evolved into scientific frameworks grounded in mathematics, physics, and measurable observation. Yet the core question feels remarkably similar across generations and cultures. Am I a participant in a vast, silent universe? Or am I a subject within a much larger cosmic story? I understand that the discovery Earth is a small planet, orbiting an ordinary star, reshaped humanity's self-perception centuries ago. Discovering we might be observed would reshape my perception of our place in the cosmos. It would challenge my understanding of uniqueness, significance, and our role within cosmic history. I have heard philosophers argue that observation alone implies a shared framework of intelligence beyond Earth. I have also heard warnings that projecting human assumptions onto unknown entities may distort objective reasoning. I know that scientific inquiry demands careful distinction between imaginative speculation and evidence-based conclusions. I believe that balance protects research from drifting into unsupported narratives or dramatic exaggeration. I see how the emotional weight of the question captures the public imagination worldwide. I notice films, literature, and documentaries often explore scenarios of distant watchers studying humanity's progress. I remind myself that while fictional portrayals are entertaining, real scientific exploration remains grounded in careful methodology. I observe international space agencies collaborating to share data, refine detection methods, and evaluate unusual findings transparently. I value that peer review ensures extraordinary claims undergo rigorous scrutiny before gaining acceptance. I appreciate that this disciplined approach prevents premature conclusions about ambiguous cosmic observations. I know researchers openly acknowledge that the search for extraterrestrial intelligence remains active and ongoing. I follow programs dedicated to scanning the skies that continue operating with increasingly advanced detection tools. I understand these efforts focus on repeatable signals, structured patterns, and anomalies that resist natural explanation. So far, none have met the strict criteria required to confirm an intelligent origin. However, I know the search itself expands our understanding of astrophysics and planetary science. I recognize that even negative results contribute valuable knowledge about star systems and cosmic processes. Meanwhile, I see Earth's technological signature growing stronger as satellite networks and digital communication systems expand. I notice large constellations of satellites orbiting our planet, creating visible patterns detectable from space. I know radio leakage from broadcasts and radar systems continues traveling outward into interstellar space. I realize our planet is gradually becoming louder within the electromagnetic spectrum. If distant observers exist, I think Earth's signal may be growing increasingly distinguishable from background cosmic noise. This possibility prompts me to consider long-term responsibility and the need for global cooperation. I ask whether humanity should coordinate a unified message that represents our species accurately and responsibly. Or do I think we should remain cautious until we better understand potential risks and uncertainties? I see these questions remain theoretical, yet they encourage international dialogue about space policy and ethics. Importantly, I note no credible scientific evidence currently confirms that Earth is under observation by extraterrestrial intelligence. To me, the hypothesis remains a stimulating question rather than a verified reality. I believe maintaining clarity between possibility and proof preserves the integrity of scientific exploration. At the same time, I feel curiosity continues to motivate researchers to refine detection strategies. I expect future telescopes and space missions will dramatically expand our ability to analyze distant planetary systems. As instruments improve, I anticipate previously invisible details may become observable for the first time. I see each advancement narrowing the gap between speculation and measurable discovery. The universe has repeatedly surprised me with discoveries once considered impossible. From black holes to gravitational waves, I have learned that reality often exceeds imagination. It therefore seems reasonable to remain open-minded while staying firmly grounded in evidence. Whether watched or alone, my quest to understand the cosmos reflects my deepest drive to explore and comprehend existence. As I explore the universe, I wonder whether something in space observes Earth. That question drives me to balance curiosity with careful, evidence-based thinking. With billions of galaxies and countless stars, I see the potential for life beyond Earth. I rely on measurable observations rather than assumptions or speculation to form conclusions. So far, I find that confirmed astronomical observations are explained by natural processes within established physics. A lack of evidence for extraterrestrial observation does not make it impossible, but it demands rigorous investigation. I know discoveries often move from hypothesis to confirmed knowledge through careful study and verification. I note that planets outside our solar system were once theoretical, and today thousands are documented. I follow ongoing research that uses advanced telescopes and instruments to look for signs of life. If other civilizations exist, they might use forms of observation we cannot detect with current technology. Our technological presence has lasted only a brief moment in cosmic terms, which makes detection difficult. Researchers and I focus current studies on signals, atmospheric patterns, and environmental data that can be measured scientifically. I consider that advanced technologies, if they exist, may observe without interfering with Earth. My colleagues and I design studies to remain objective, seeking verifiable data rather than unverified claims. I consider natural explanations before entertaining unusual possibilities. Expanding detection methods helps me and my colleagues refine our understanding of the universe. New telescopes allow me and other researchers to analyze distant planets for atmospheric compositions that may indicate natural or biological activity. Even subtle observations contribute to our knowledge without assuming intelligent presence. Careful evaluation ensures my conclusions are grounded in verifiable evidence. I believe extraordinary claims require extraordinary proof and must meet scientific and ethical standards. I see that public interest in space exploration inspires learning, but should remain factual and safe. I avoid promoting fear, speculation, or misinformation when I communicate about space. I observe that Earth continues in its orbit according to natural laws, without verified interference from external sources. Daily life on our planet proceeds under predictable natural processes. Scientific observation lets me explore space responsibly without assuming intent from unknown sources. My responsibility is to keep learning, sharing knowledge, and advancing research carefully. Every discovery, study, and report I read contributes to a broader understanding of Earth and space. The signals we send into space reflect technological progress and natural exploration. I believe observers, if they exist, would likely see natural patterns and technological signals rather than harmful activity. I find that studying the universe promotes curiosity, education, and cooperation across scientific communities. I feel that understanding Earth as part of a larger cosmic context encourages thoughtful stewardship. The possibility of observation motivates me to pursue careful, responsible research and technological development. My colleagues and I continue refining instruments and methods to improve knowledge about distant planets and stars. Exploration helps me and others understand Earth's place in the universe while remaining safe and evidence-based. Every advancement in technology and astronomy improves our ability to observe and study space responsibly. Our actions reflect how we interact with knowledge and discovery rather than any external judgment. Questions about observation encourage me to reflect on ethics, responsibility, and scientific integrity. In my research, I focus on observable data, patterns, and natural phenomena, avoiding speculation and sensationalism. I believe evidence-based exploration ensures findings remain credible, transparent, and safe to share. I encourage curiosity balanced with rigorous methodology when studying space. Understanding Earth's signals and technology prepares me and others to engage responsibly with potential discoveries. For me, the night sky inspires learning, science, and observation. Silence in space allows me to focus on measurement, analysis, and careful data collection. New discoveries expand my understanding while staying aligned with verified scientific principles. Until further evidence emerges, I will continue observing, learning, and exploring the universe responsibly and safely.